Hi, everyone, and welcome to this next installment in this series of algebra videos. In this one, it's going to be a pretty targeted video. I'm only going to be talking about one topic, and that one topic is the difference quotient. And I want to be more specific. When we say the difference quotient, we should, say it's implied here. We're saying the difference quotient of something, the difference quotient of a function. So you have to start with a function first. You can't just like out of nowhere say, what is the difference quotient? It's the difference quotient of something, of a function. Now, in my next video, after this one, I'm going to be talking about a specific class of functions, linear functions or straight lines. So we haven't up until this point really defined the different components or characteristics of a linear function, but it's possible maybe you've heard the term slope at some point in the past. Generally, we talk about the slope in reference to a straight line. So the slope of a line is equal to the change in y values divided by the change in x values. So let's say here's a straight line. If we wanted to calculate the slope of this line, we would take any 2 points. It doesn't matter where they are. Any 2 points. Right? We call those 2 points point number 1 and point number 2. And so I can't call them both x, y, because they're going to be different x values and different y values. So we'll call this x1 and x2. We'll call this y1 and y2. This is just saying first x value, first y value, second x value, second y value. And the slope is equal to the change or the difference between the y values. Difference means subtraction. So we take y value minus y value. We usually do bigger minus smaller. And divide that by x value minus x value. Right? That sometimes it's referred to, sort of conversationally as rise over run. Right? But these are all things I'm going to be talking about in more detail in my next video. But I think it's going to help in this one to just talk about what the difference quotient is. So we have this formula for slope. Take 2 points. Each point is an x and a y. To find the slope, you subtract the y values. That's the top of your fraction. You subtract the x values, and that's the bottom of your fraction. Okay, so that's the slope of a line. We've seen the graph of many different functions so far. If you think about the previous sections we've covered, previous videos, straight lines we've graphed, absolute values, square roots, quadratics, cube functions. We've graphed a number of different functions. So not every function, obviously, from what we've seen, not every function is a straight line. So generally, when we talk about slope, we talk about the slope of a straight line. Maybe next semester in calculus, you'll talk about the slope of a curve or the instantaneous slope at a point, but that's a different topic altogether. So let's say, let me do something that's going to be nice on here. Let's say we've got something like that. We don't need to know what we don't need like an equation for this. We don't need f of x equals, something that's going to be maybe a cubic function, but it doesn't matter what the function is. Right? So this is obviously not a straight line. So we can't use our slope formula, because with the slope formula, you should get the same answer regardless of whichever 2 points you use. So if I pick this red point and this red point, the slope between them is going to be one thing. But if I choose, let's say, this green point and this green point, it's going to be a different slope. All right, so the difference quotient is basically, oh, I lost my graph. Let me bring that guy back. The difference quotient Not happy with that one. Let's do something like that. The difference quotient is a function that tells you the slope of what's called the secant line. And a secant line, don't make this more complicated than it needs to be. A secant line is any line that crosses your graph twice. Any line that crosses your graph twice is we call this it a secant line. Different secant lines will be in different directions. The slope, you could think about the slope as being the direction of the graph. If I draw this secant line, different slope. This secant line, different slope. All right, so I'm just going to stick with the red one. Now, I just previously said that the slope of a line, not y, slope, actually the symbol for slope is m, but we're not going to introduce that just yet. Slope is equal to y value minus y value. You got two y values because you got 2 points. y2 minus y1. And you've got two x values because you got 2 points. X minus x. So this would be the first x value, and this would be the second x value. Okay. This would be the first y value, and this maybe about right there would be the second y value. Okay, so the x and the y coming from the red dot, the red point on the left, and the x and the y coming from the red point on the right. So what we're going to do here is just replace the x's and y's with some different notation. Right? We're going to use the same 2 points, the same red line, so it's going to be the same slope. All I'm doing is changing the language. Right? I'm translating from the language of equations to the language of functions. And I've talked about, I've referred to that translating between equations and functions, a number of times by now. So when we're talking about equations, here's our formula for slope. Now when we're talking about functions, I'm not going to use x's and y's. I'm not going to use x1 and y1. I'm going to use just x, just one x. I'm not going to call it x1. There's going to be no x2. It's just x. So for that first point, I'm looking at this one right here. For this first point, the x value, I'm calling it x, and the y value is f of x, because we're talking about functions. All right, so we have the first point. Is x comma f of x. The second point, I'm not going to give that necessarily a symbol on its own. I'm going to say, well, this distance between them. Distance, let me use a different color because this is where the formula comes from. Right here is where the difference quotient is coming from. So let's say from this x value to this x value, the distance equals, let's say h. H is some number, right? H is some positive number. So that means you're taking the first x value and you're adding h to it. You're taking the first x value and you're adding h. So this will be x plus h. Okay, so that second point, the x value is x plus h. And then the y value is going to be whatever you get when you plug x plus h into the function. This is the function f of x, this blue graph. All right, so if you plug x plus h into the function, you get f of x plus h. All right, so now we've got two x values and two y values. But instead of using x's and y's, we're using two x values that are this far apart, h units apart. H could be any number, any positive number. So two x values that are h apart, and then the y values, instead of using y's, we're using f of x's. So second, or the y value of that second point is f of x plus h. So if we take the slope formula and replace the x's and y's with these, what we have here in red, we'll get that the slope is equal to, we do the same thing, y value minus y value divided by x value minus x value. So we get f of x plus h minus f of x, so the y minus the y, divided by the x. So the x plus h is one x value minus the other x value. So on the bottom, looks like those x's cancel. We have a positive x and a negative x. So that gives us f of x plus h minus f of x all divided by h. And this is what I'm highlighting in green. This is the difference quotient. And this is where it comes from. We take the formula for the slope of a line. That formula is written in the language of equations, the y2 minus y1 over x2 minus x1. So we take it from the language of equations and translate it to the language of functions. And when we talk about functions, just it looks different, but it tells you the same thing. The slope of the line between 2 points, nothing more and nothing less. So let's do a specific problem. Let's do a specific problem. I'm only going to do one. Find the difference quotient for the function f of x equals x squared minus 2x. Now, told you, you have to start with a function. You got to have an f of x, right? And from that function, you could then come up with the difference quotient. Now, the difference quotient it's got three pieces. It's got the f of x plus h. So you're taking that. And that's going to be, in this case, some polynomial. You've got the f of x. And you've got the h. Okay, so there's three pieces here. So let's compartmentalize this problem. Let's look at only the yellow part. Only the yellow part. So f of x plus h. That means we take the original function, and everywhere you see an x, you replace it with an x plus h. All right, so let me just, I'll color code this with the highlighter. We're taking this x, I just made that yellow, and this x over here. I'm replacing those two. Just, let me put the arrow the other way. We're putting in here an x plus h, and we're putting in here an x plus h. All right, and now it comes down to something we've already done before: multiplication of polynomials, addition, subtraction, multiplying, dividing polynomials. We've done that already. Well, at least addition, subtraction, and multiplication for sure. In this case, multiplication, subtraction. All right, so anything squared means you take that thing and multiply it by itself. So x plus h squared means x plus h times x plus h. And the 2 times x plus h, we can multiply through the 2 or distribute the 2. So that'll be minus 2x minus 2h. All right, the difference quotient is there's going to be some steps here. There's going to be some steps. So if we multiply this out, now this sometimes is referred to as FOIL method. So one mnemonic device that's used for this part. X plus h times x plus h. First times first, outer times outer, inner times inner, last times last. So there's going to be four multiplications that happen. X times x, which is x squared. Outer times outer is x times h. So that's plus xh. So we did first times first, x times x. Outer times outer is x times h. Inner times inner is another x times h. I'll use the same order. And then last times last is h times h, which is h squared. So that becomes that. And we still have a minus 2x and a minus 2h. Now, combine like terms, there's not much to combine, but we could at least combine two of them. I'm looking right here. We've got two of those xh's. Two of those. So we could say x squared plus 2xh plus h squared minus 2x minus h. Okay, so let me do a little more color coding here. This, where we're at, this answer here is not the final answer. Pen, I need a red pen, not a red highlighter. So this yellow part is this right there. It's that piece of the difference quotient. So instead of trying to do the whole thing at once, start off by just figuring out the f of x plus h. And now that we have that, we could say, okay, f of x plus h minus f of x all over h, this is the difference quotient, is equal to what we have in yellow, right? Remember, that's just that part of it. That's just that part of it. So that's x squared plus 2xh plus h squared minus 2x minus h. There's an h on the bottom. And then you've got this part. What is it? Which I'll use green for this. Minus the original function. Minus the original function. So the original function, that's given. That's x squared minus 2x. So you are subtracting the original function minus x squared minus 2x. Now, some stuff is going to cancel here, and that's the point. We want to be able to reduce this and get rid of the h on the bottom Why do you get rid of the h on the bottom? Well, that's not important until you get to calculus 1, and then it becomes extremely important. But we should hopefully be able to cancel off that h on the bottom. Let's see, does anything cancel? Well, first let me highlight this green, because that is the f of x portion. And we got green in the formula, green in our answer. Now, definitely some stuff cancels. We've got an x squared and a minus x squared, because this negative sign is, we're minusing both of those guys, right? So we've got this x squared here and this x squared here. They cancel. Boom, boom. We've got a negative 2x, and this is actually a positive 2x on this side, because we have a minus and minus. We have the minus on the outside, the blue one, and then a minus in the green. So that's two negatives make a positive. So this negative 2x will cancel this positive 2x. Running low on space, but we're about 2 steps away. So what's left? We've got 2x h. We've got h squared. And we've got minus h. There's still an h on the bottom. Right? We still have that. We still have that. And we still have that. So we can factor. If you look at the top, 2xh plus h squared minus h, there's a common factor there. There's a common factor. So we could factor out that h. So we're left with 2x plus h minus 1. Something doesn't look right. Oh, let me go back a couple of steps. I'm so sorry about this. Right here, I stopped writing the 2. There should be a 2 next to that h. Sorry about that. Let's just make that change. So there's a 2 here. Okay. I hope that doesn't cause too much confusion. But yeah, that should be it. I had it in the first step, second step, third step, and then I lost it in the fourth step. So there's a 2 there. So that's actually a minus 2. 2x plus h minus 2. And then we still got the h on the bottom, but factoring out that h, now that allows us to cancel the h top and bottom. And so our final answer, really running low on room here, but I'll just circle it. Our final answer will be (2x plus h minus 2). Okay, so we talked a little bit about what the difference quotient is, what it represents, where it came from. It is the slope of a line. It's just the slope of a line. When you're using notation for a function, obviously it's more complicated than finding the slope of a line, because it's not only restricted to straight lines. It's any function. Let me go back one slide just for a moment. Any function, if you have the graph of a function, you could always pick 2 points and draw a straight line through them. So that straight line through those 2 points will have a slope, but it's going to be different for different points. That's why it ends up being a function and not a number. But the difference quotient gives you the slope of this red line. Okay, that does it for the difference quotient. I hope this was helpful.